Physics warriors, welcome back to the channel. I'm Tanya, your personal coach, who is here to turn paper 2 into yes, I can do this. This video, we're going to talk about the final boost you need to push your marks over the edge, eyeing the beautiful A star. And listen, paper 2 is not just about the luck or guessing. It is about understanding the patterns, mastering the traps, and moving faster than Sonic. So grab your pen, pause if you need, and let's dive in because this might be the most valuable time before your exam. Now, this is it. A reminder. So, link has been posted in the description. If you need the PDF of this, you can actually download it. Link is already attached in the description. This is the top tips to score in your IGCSE Physics 0625 Paper 2 multiple choice, right? Let us look at the tips here that I'm going to discuss. First tip, you have to know about the format. You have to be familiar with the format of paper 2. So paper 2 consists of 40 multiple choice questions, 1 mark each. So if you answer 40 questions correctly, you gain 40 marks. And it covers the full syllabus from your year 10 to year 11 syllabus and no partial credit, right? Or you get all full mark or you get nothing. If you get it wrong, right, you got wrong answer, you get 0 mark. If you get correct answer, you get full mark. That's all. Tip number 2, unit conversion. You know, paper 2 is quite tricky. They sometimes, right, they give you something, right? It is not about the number. It's about the units. You have to know the conversion of the units. This is very important in paper 2. And make sure that you read the units correctly. And beware of all those prefixes. Don't worry, I've got you covered. I will give you some examples of the parts here to discuss with you the tricky part of the questions. No worries. Right, let me give you some examples of the prefixes. Like 1 mega. Mega means 10 to the power of 6. 1 times 10 to the power of 6. That is called mega. So it consists of 6 0. 1, 2, 3, 4, 5, 6 0. If you're going to convert to joules, 1 kilometer is equal to 1,000 meter. So you have to memorize the basic unit conversions correctly. Right. Now, tip number 3, you have to memorize and you have to use formula from the IGCSE physics syllabus. So most of the formula are not being given. But don't worry, like what I say, I've got you covered. So we are moving on, right, to the equation or the formula. They are very important. So I have some important formulas that I want to discuss in this video itself. Now, if you physics, right, you enter the examination hall, right, without knowing a single formula, don't you feel like you are like a footballer entering the football field without wearing the football shoes? Like wearing a slippers, so you are not get well prepared for that. That is why you need to know certain formula before you enter that examination hall. Now, formula number 1 is quite basic. It is density. Now, the symbol of density is called rho. It can be calculated from mass over volume. Beware of the unit of density, right? So the unit of density could be gram per cm cube volume, right? Or kilogram per meter cube. Now, let us try some partial questions, paper 2. Diagram shows a cuboid block made from a metal of density 2.5 gram per cm cube. What is the mass of the block? No, density is given. Just write down the equation of density. Density is equal to mass divided by volume. Density is measured in gram and the volume is in cm cube. Look at the unit of density. That is why if you want to find the volume of the cuboid, you need not have to convert the cm to meter. So density, okay, mass must in gram. Look at the unit of density. This is gram. So you just put 2.5. Mass, I don't know. Volume, length, times height, times width, right? So the mass would be equal to 2.5 times 2 times 2 times 10. So you get 100 gram, right? Check the unit of density. This is gram. This is per cm cube. This is cm cube, right? So the answer is D. The next one, the next formula, this is average speed. Now, average speed is not like how you calculate the average value in math, right? If let's say a number of speeds are being given, like let's say 3 speeds are being given, 10 meter per second, 20 meter per second, 30 meter per second, you cannot just add out all the speeds, right? Divided by the number of speeds. That is wrong. Average speed, no choice. You have to use formula to do your calculation. Average speed can be calculated by total distance divided by total time. So let us see. One of the past year questions here. A train begins a journey from a station and travels 60 kilometers in a time of 20 minutes. What is the average speed of the train? Now, before you answer the question, write down the equation. It brings no harm when you write down the equation. Average speed is equal to total distance divided by total time. Look at the units, right? The next step is to look at the units given, right? The units given are in meter per second. Could you see that all the choices are in meter per second? But the unit given here is in kilometer. Distance is in kilometer. So you have to change that distance to meter. So first thing you do, 60 kilometer, you change to meter, you times 1,000. And time is given in second, but the time here is 20 minutes. So 1 minute is equal to 60 seconds. 20 minutes, you times 60. That is in second. So when you do your calculation, right, you should get 60,000 meter divided by 1,200 second. So the answer is 50 meter per second. C is the answer. The next one, Formula 3. This is momentum, right? Momentum can be calculated by mass multiplied by velocity. And change in momentum is final momentum minus initial momentum. This is called final momentum. Why? Because mv related to, m is mass, v is related to final velocity. And u is related to initial velocity. This is called initial momentum. And one more thing, impulse, right? There are two equations to calculate impulse. So it depends on the question. One is change in momentum, mv minus mu. The other one is force multiplied by time. So the unit of momentum, change in momentum or impulse can be Newton second or kilogram meter per second. And I want you to be extra careful when you solve questions regarding momentum, change in momentum, as well as impulse. Why? Because momentum is a vector quantity, right? Especially regarding change in momentum. If you see the word like this, these are the keywords, right? Rebound, reflect, moving in opposite direction, that is in mind, right? You have to do some modification. So you have to put positive to one direction because rebound, reflect, moving in the opposite direction, meaning to say that the direction has changes. So you have to put positive to one direction and negative to the other direction. So be extra careful on that. So let us look at one past year question right here. An object of mass 50 kilogram accelerates from a velocity 2 meters per second to a velocity 10 meters per second in the same direction. Wow, this is the keyword. This is same direction. So that means this is an object moving 2 meters per second, and then after that still moving in the same direction but increasing. Speed is increasing. Right? What is the impulse provided to cause this acceleration? If you want to find the impulse, remember, there are two equations of impulse. One is the change in momentum. The other one is force multiplied by time. In this case, I am going to use impulse as mv minus mu because the force is not being given. right? Mass is 50, final velocity is 10, minus mass 50, initial velocity is 2. So this is 500 minus 100. So the answer is 400 Newton second. B is the answer. The next formula is resultant force. Remember, resultant force is the sum of all the forces that are acting on one object. Sum. That means the addition of all the forces that are acting on one object. Resultant force is being defined in Newton's second law. So resultant force can be calculated from m change in momentum divided by time. Remember that. Right? So if you factorize it out, the m, you will get v minus u over t. So this v minus u over t is the definition of acceleration. That is why resultant force could also be written as F equals to ma or F equals to mv minus mu over t. So these are the two equations that you can memorize. Now let us try some question. A force F acts on a body of mass m for a time t. During this time, the velocity of the body increases from u to v. Right? So they didn't say rebounds, they didn't say change direction, so you are safe. Which equation relates F, M, T, U, and V? So just use resultant force is equal to change in momentum per time taken. So times up the t, cross multiplication, Ft is equal to mv minus mu, and then Ft is equal to mv minus u. So C is the answer. The next one. An object of mass 1.2 kilogram is moving with a velocity of 2 meters per second when it is acted on by a force of 4 Newton. Velocity of the object increases to 5 meters per second in the same direction. So when they mention same direction, right, you can feel relief because you don't have to consider direction anymore, right? Put positive to both directions, right? For which period of time does the force act on the object? It seems to be so complicated. You know, when I see the question, if I am so blank, I don't know which equation or which formula should I use. I always put this down. M is mass. Moving with a velocity, the first velocity that is being stated is its initial velocity. Force is F, and this is final velocity. It seems to be like a trend like that. So I'm going to use F equal to mv minus mu over t. I'm supposed to find t. So t is equal to mv minus mu over F. M is 1.2, v is 5, minus 1.2. Initial velocity is 2, and the force is 4 Newton. So you get 0.90 second. A is the answer. The next one, formula number 5, weight, right? Weight W is equal to mg. Remember, weight must be measured in Newton because it is the gravitational force. That is why if your mass is given in gram, convert it to kilogram. You have to, right? This is called mass. And the G, this is called gravitational acceleration. It is 9.8 meter per second squared. Remember to convert your mass from gram to kilogram. This is very important. So let us look at one passive question right here. An astronaut of mass 80 kilogram is standing on a planet with a gravitational field strength G equals 3.8 Newton per kilogram. What is the weight of the astronaut on this planet? Just put in W is equal to mg, weight, mass times 3.8. So you get 304 Newton, which you can round it off to 300 Newton. B is the answer. Next one, formula 6, moment. You know, moment is the turning effect that caused by a force, right? How to calculate moment? Force multiplies by perpendicular distance from pivot. What is pivot? Pivot is a turning point. So first of all, before you solve any question regarding moment, you have to identify the pivot first. Force and distance must act perpendicularly to each other, right? And then, okay, since moment causes turning effect, so the object could turn in clockwise or anti-clockwise direction, right? The unit of moment could be Newton meter, Newton cm, Newton mm. Force must always be in Newton. Perpendicular distance, it depends on the question. Right, principle of moment. This is one of the conditions for a system or an object to be in equilibrium. So the principle of moment states that for a system or object to be in equilibrium, the total clockwise moment must always be equal to total anti-clockwise moment. Let me erase this. Total anti-clockwise moment. Just remember this. Now, let us try some question here. A beam is pivoted at one end, has a force of 5 Newton, acting vertically upwards on it as shown. The beam is in equilibrium. When you see this, you have to know right away. If you want to use moment, then you can use moment stating that clockwise moment is equal to anti-clockwise moment, right? And then, what is the weight of the beam? Okay, before you start to solve question regarding moment, right, you have to identify the pivot first. I have already identified pivot is here. Question has already mentioned that's pivot. After that, the next thing that you have to do is identify the forces that are acting on the system. There are two forces. Then determine the direction, right, of turning, whether this force will cause a turning effect in clockwise direction or anti-clockwise direction. How to see? You look at 5 Newton first. 5 Newton is going upwards. Where's the pivot? Pivot is on its left-hand side. So 5 Newton going outwards because this is moment, right? The force will cause a turning effect. So this force will have to turn towards the pivot. Going out while turning towards the pivot, this is called anti-clockwise. This force produces anti-clockwise moment. So the weight of the beam, which is acting downwards, going down while seeking for the pivot. So it causes clockwise moment. Then just form your equation. Clockwise moment equals anti-clockwise moment. First of all, clockwise moment, this is the weight of the beam. I don't know the weight, I have to find. Times the perpendicular distance between the force and the pivot. This is what I call 90 degrees. Perpendicular distance between the force and the pivot. So the perpendicular distance is 3 cm plus 2 cm, which is equal to 5 cm. Equals anti-clockwise moment, 5 Newton, times the perpendicular distance between the 5 Newton and the pivot, which is 2 cm. So times 2 cm. 5 Newton. Weight is equal to 5 Newton times 2 cm divided by 5 cm. Cm cancel, 5 and 5 cancel. So your weight is equal to 2 Newton. A is the answer. Let us try more question. What about this? A weightless beam is balanced. When I say balanced, it also means that clockwise moment is equal to anti-clockwise moment. On a pivot, as shown, forces P, Q, R add on the beam. Which equation is correct? First of all, what are you supposed to do? You are supposed to determine your pivot. Second step, determine the forces. Okay, how many forces here? I have P, Q, and R. 3 forces here acting on the beam. Third step, identify whether these forces will produce clockwise or anti-clockwise moment. Look at P first. P going downwards. While going downward, it will turn towards the pivot. This is anti-clockwise moment. Q is pointing upwards. While going upwards, it will turn towards the pivot, which is down there. This is called clockwise moment. What about R? R is moving downwards. While moving downwards, the pivot is on its left, so it will turn to the left. This is also called clockwise moment. Yeah. And after that, what are you supposed to do? Just put anti-clockwise moment is equal to clockwise moment, right? So anti-clockwise moment, anti-clockwise moment will be anti-clockwise moment is equal to clockwise moment. Total anti-clockwise moment is equal to total clockwise moment. So this is anti-clockwise, this is clockwise. So P times distance D is equal to clockwise moment. Okay, this is P and D. This is anti-clockwise. Clockwise is Q times perpendicular distance from the pivot, B, plus, this is also clockwise, R times the distance, perpendicular distance between R and the pivot, this is A. So I don't have PD, right? But I have P times D minus Q times B, right? Because I shift this Q times B is equal to R times A. So the answer is D. The next one, formula number 7, Hooke's law equation. So still remember, Hooke's law states that extension is directly proportional to the force applied beneath the limit of proportionality. So Hooke's law, F equals kx. Remember, this F, sometimes they mention it as a load. Load is a force. Newton, right? X extension, it depends. Could be cm, could be meter, could be mm, right? And K is called spring constant. Right, when a graph is being given, there are two types of graph that could be given. This is force against maybe extension in cm, or extension against force. So you have to beware. But both graphs will give you a straight line graph starting from origin. So if you get force against extension graph, if you want to find your K, spin constant, you just take F, the value of F, the force, divided by extension. But if you want to find is extension force graph is being given, you want to find the spring constant, still the same, just put the value of force. It's just that the value of force is in the x-axis. So you have to be careful. Look at it carefully over extension. Now, another thing is about elastic potential energy. When a graph is being given, elastic potential energy is area under the graph. So elastic potential energy is half Fx, because this is the area of triangle, right? Or you can also replace F with Kx, so you can, okay, another expression for elastic potential energy is half Kx squared. Now, let us try some example right here. Objects with different masses are hung on a spring. Diagram shows how much the spring stretches. Extension of the spring is directly proportional to the mass hung on it. What is the mass of object M? So if I want to get a mass of object M, and the mass is in gram, right? So I use Hooke's law, F equals to kx. Remember I told you about F must be in Newton, right? So, but F is not being given. So F can be calculated by mass times 9.8, yeah, meter per second. But this mass, I'm not going to change to kilogram. I'll just put it in gram first, right? 9.8 F is equal to the weight, actually. Weight is equal to mg, if you must know, right? Which is equal to the spring constant times the extension. Extension has to be final length minus original length. How do I know that 10 cm is an original length? Original length is the length of the spring when the spring is not attached to any loops or masses, right? So 30 minus 10, M in gram here times 9.8 is equal to K. This is 20 cm. Right, I don't have a K value. I don't have a spring constant. But since the experiment is being conducted by using the same spring constant must be the same. So I am going to find my spring constant right now, right? By using these two diagrams, right? One is F equals to Kx. This mass, I'm going to put it in gram as well, times 9.8 equal to spring constant times extension between these two. When 100 gram is being hung on a spring, this is 20 cm minus 10 cm. So mass, this is 100 gram times 9.8 equals to K times 20 minus 10, this is 10 cm. So K value is equal to 100 gram times 9.8 over 10 cm. I sub into this equation. So M times 9.8 equals K. I'm going to sub it in with 100 gram times 9.8 divided by 10 cm and times 20 cm. And I want you to see this. I cancel the cm. I cancel the gram. Oh no, I cancel the 9.8. Right, so I left M equals 100 gram times 20 divided by 10. So M is equal to 200 grams. The answer is C. Formula number 8, work. Work, you have to beware. It is the force multiplies by distance. Move in the direction of force. That means if the force is forward, the distance must be forward as well. Right? You have to resolve the distance in the direction of force, or you resolve force in the direction of the distance. Right? Work, the unit of work is in joules. That is why the force must be in Newton, distance must be in meter. Right. And then you have gravitational potential energy, which is GPE, can be calculated from mgh. M must be in kilogram because gravitational potential energy is measured in joules. G is 9.8 meter per second square. H is the height. Height must be measured in meter. And you also have kinetic energy, which is Ke, which is equal to half mv squared. Kinetic energy is also measured in joules. That is why your mass must be in kilogram. This is your speed. Speed must be in meter per second. You have to square it. Now, let us try one question here. A lorry of mass 4,000 kilograms is traveling at a speed of 4 meters per second. A car has a mass of 1,000 kilograms. Kinetic energy of the car is equal to the kinetic energy of the lorry. What is the speed of the car? Right, so I'm going to draw a lorry first so that you can see this is a lorry. Mass of the lorry is 4,000 kilograms. And then lorry is traveling with the speed of 4 meters per second. And I have a car. And then the mass of the car is equal to 1,000 kilograms. And the speed of the car, I don't know. Right? But I have another relationship here. Kinetic energy of the car is equal to the kinetic energy of the lorry. So I can do now, kinetic energy of the car is equal to the kinetic energy of the lorry. Kinetic energy of the car is half mc means car, v of the car square is equal to half ml means lorry, v of the lorry you square. Right now, I cancel the half. Sub in the value, mass of the car is 1,000. Speed of the car square is equal to mass of the lorry is 4,000. And the speed of the lorry is 4, but you have to square it. Be careful with the square. Right? So, speed of the car, you square, you get 4,000 times 16. 4 square, you get 16 divided by 1,000. From here, right, you will get, okay, let me do it because I don't have the value just yet. 4,000 times 16 divided by 1,000. So I get 64. So speed of the car square is 64. Now, I want the speed of the car. So you square root 64 and you get 8 meter per second. C is the answer. What about this? A boy uses a rope to pull an object of mass up a slope. So I draw a slope. Okay. And this is the mass of the object. See that? Up a slope. The tension in the rope. Okay. Tension is equal to F. Object moves the distance d along the slope. Okay, this is distance d. Okay, from center to the center, this is the distance d, and the height of the slope is h. You see, they're testing you on your understanding of the work done. Work done, remember, the force must be occurring, the direction of the force and the distance must be the same. You cannot use h because h is acting vertically. Right? So force times distance. A is the answer. Formula number 9. This is related to power. Power can be calculated by work done per time or energy. Whichever energy. Could be gravitational potential energy divided by time or kinetic energy per time. And the unit of power is watt, or capital W. Work done must be in joules, time must be in second. Energy is in joules, time must be in second. Remember, this is very important. Now, let us try one past year question right here. A pump does 460,000 joules of work to raise water to fill in a tank. It takes 7 minutes to fill the tank. What is the power of the pump? You see, power is equal to, this is work over time. Remember what I told you just now? I say the time must be in second. This is minutes. So you have to change that minute to second. So 420 seconds. Right, so work 460,000 joules divided by 420 seconds. So 460 divided by 420, and you end up getting 1095. And there's a button between 7 and 8 of your calculator. Press the button of E and G. So you will get, okay, 1.1 times 10 to the power of 3 watt, or 1.1 kilowatt. A is the answer. The next one is formula 10, efficiency. There are 3 equations of efficiency, right? All these you have to memorize. One is useful output power over input power times 100%, or useful output energy over input energy times 100%, or useful output work divided by input work multiplies by 100%. Right? Now, let us look at this past year question. Diagram shows the energy used by a modern lamp. Which expression gives the efficiency of the lamp? So efficiency, it has to be related to useful power divided by input power. So times 100%. That is why the answer is A. Useful output power is 12. Ignore the wasted power. Divided by 60 times 100%. Next one, a machine has a power input of 200 watt and a useful output energy of 1 kilojoules in 6 minutes. What is the efficiency of the machine? Efficiency, because the power is being given, so I'm going to use the useful output power divided by input power multiplies by 100%. So the useful output power, okay, that is useful output energy. Energy must be in joules, but this is given in kilojoules. So that is why I'm going to change that. 1 times 1,000, that is 1,000 joules here. 6 minutes, time must be in seconds, so you have to change your time. 6 times 60. right? 360 seconds. Right, then find your useful output power. Power, remember, power is equal to energy per time. That is why you take 1000 divided by 360 to get your useful output power, which is 2.78 watt. So I sub in here 2.78 watt divided by input power 200 watt times 100%. So the answer is 1.38%. You can round it off to 1.4%. The answer is C. The next one, formula number 11, pressure. So the definition of pressure is that pressure is equal to force per area. Area of the base, right? Pressure, the force can be Newton, but if the area is measured in meter square, your pressure will be Pascal or Newton per meter square. But if your force is Newton and your area is mm square or cm square, pressure will be Newton per cm square. Cannot be equal to Pascal. Pascal is when the unit of pressure, which is equal to Pascal, is only valid when the unit of force is Newton and the unit of area is meter square. Right, and sometimes, right, when the density of the fluids are being given, fluids means gas and liquid, you can also calculate pressure by using P is equal to rho GH. So rho represents density, G represents gravitational acceleration, 9.8 meter per second square. H is the height measured from the ground, or the depth of the liquid measured from the surface of the liquid. That's all. Now, let us try one of the past year question. Diagram shows a rectangular block of weight 16 Newton. It is resting on a flat surface. What is the pressure at the base of the block due to its weight? So just write down the formula of pressure. Force over area. So the force is actually the weight, which is equal to 16 Newton, and area of the base. This is the area of the base, or this is. So 4 cm, not going to change that cm to meter because the units are in cm. 4 cm times 5 cm. So the answer is 0.80 Newton per cm square. C is the answer. The next one, a dam. Oh, this is a very favorite positive question. A dam holds water in a reservoir. The height of the water in the reservoir is 15 meter. Density of the water is 1000 kilogram per meter cube. What is the pressure due to the water at the bottom of the dam? So when the density is being given, always write this equation, P equal to rho GH. So rho is the density, which is 1000, G is 9.8, and the height is 15. Measure from the surface of the water, right? So you will get 147,000 Pascal, or you round it off to 150,000 Pascal. D is the answer. What about this? An object is at a depth h below the surface of the liquid. Pressure due to the liquid at this depth is rho. Is P, sorry. Pressure is P. It looks like rho. Gravitational field strength is G. What is the density, rho, of the liquid? Now, let me draw. This is a liquid, and this is an object. This is the height, the depth. Okay, and pressure is P here. So density, just use P equal to rho GH. When the density is being given, always use this equation. Now I want to find density, make density as a subject, P over Hg. D is the answer. Now the next formula is specific heat capacity. When you see the word specific heat capacity, always use this equation. E equal to mc delta T. E is called thermal or heat, right? Thermal energy or heat. M is the mass. C is called specific heat capacity. And delta T is the change in temperature. And sometimes when a heater is being used and the heater comes with power rating, right, they don't really give you the energy. So you have to modify the equation. When the heater is being used and you want to find the energy, remember the equation of power is equal to energy over time. So if you want to find the heat or the energy, energy is equal to power multiplied by time. Power must be measured in watt and time must be in second, remember. Now, let us look at this passive question. Thermal energy delta E is supplied to an object of mass m, which does not change its state during the heating process. Temperature of the object rises by delta T. What is the specific heat capacity of the object? Right, just write down, when you see the word specific heat capacity, E equals to mc delta T. In this case, sub in whatever given, delta E is equal to mass times specific heat capacity times delta T. So the specific heat capacity would be delta E over M times delta T. So A is the answer. Now, formula 13, period vs frequency. Period is the time taken for one complete oscillation. Frequency is the number of complete oscillation in time given. So that is a relationship between period and frequency. Period or frequency can be calculated by 1 over period. Right, and the wave speed V is equal to F lambda. This is wave speed V, F is frequency, lambda is called wave length. Now, look at this. Sound waves of frequency 2 kilohertz travel through a substance at a speed of 800 meters per second. What is the wavelength of the wave? When they give you the frequency, they give you the wave speed, always use V equals F lambda. So the wave speed is in meter per second. Look at frequency, kilo. You have to change that kilo. So 1 kilo is 1,000. So times 1,000, you get 2,000 hertz. Now to find the wavelength, this is wave speed 800, frequency is 2,000, and wavelength. Wavelength is called lambda. So lambda is given as 800 divided by 2,000. So your answer should be 0.4 meter. A is the answer. The next one, refractive index. So refractive index, the symbol is N, right? So it can be calculated by psi incident angle over psi refracted angle. Incident angle is the angle between the normal and the incident ray. Refracted angle is the angle, okay, this is what we call incident. This is normal. What is normal? Normal is just an imaginary line which is acting perpendicular to the two surfaces. Right, so this is incident angle. This is refracted angle. So if the light travel or the wave travel from less dense medium to denser medium, you can find your refractive index by using psi I, this is called I, over psi R. Okay, when this is only valid when wave travels from less dense medium to denser medium. Right. Another equation for the refractive index is N equal to psi R over psi I. This is only valid. This is air. This is water. Only valid when the wave travel. This is called I. This is called R. Right. This is only valid when the wave travel from when wave travels from from denser medium to less dense medium. And then you also have refractive index is equal to the speed of light in air and in water, speed of light in air or in vacuum divided by speed of light in medium. Speed of light in air I already gave you, which is 3 times 10 to the power 8. right? Meter per second. Or you can also calculate refractive index by using the real depth divided by apparent depth. So you might be wondering, there are so many equations for the refractive index. How am I going to memorize all these, right? Don't worry, especially sine I over sine R or sine R over sine I. I give you one important tip. How about that? Right, whenever you do your calculation for a refractive index, make sure that the value of the refractive index must be more or equal to 1. So if you get a value which is lesser than 1, your calculation is totally wrong. Remember that. Yeah? So it doesn't matter whether sine I is over sine R. Make sure that if you get a value more than 1, that is correct. Right, like for this one, which calculation gives the refractive index of the glass? So you could see that light, okay, is ray of light is traveling from air, right, to glass. See that? First of all, identify which is your incident angle. This is the incident angle. 40 degrees. 90 minus 50 is 40 degrees. Incident angle is the angle between incident ray and normal. Refracted angle, yes, 25 is the refracted angle. So since the light travel from air to glass, right, less dense to denser, so you put refractive index is equal to sine 40 divided by sine 25. You will get a value which is more than 1. But if you memorize wrongly, let's say you put sine 25 divided by sine 40, you get a value which is lesser than 1. So you know that you have calculated wrongly, right? So A is the answer for this one. The next one, a ray of light is refracted as it enters air from glass as shown. What is the speed of light in the glass? Now you see this? First step, identify the incident angle. This is called incident angle. 90 minus 60, you get 30. Light travel from, okay, I need to find the speed of light. Speed of light is equal to 3 times 10 to the power 8 in air over speed of light in glass. I have two unknowns. So from the angles given, I can find my refractive index. N is equal to sine 50, take a larger number, divided by sine 30 degrees. Get a value for your refractive index. Sine 50 divided by sine 30, I got 1.53. So 1.53, so just sub in here 1.53 is equal to 3 times 10 to the power 8 over speed of light in glass. So speed of light in glass is equal to 3 times 10 to the power 8 divided by 1.53, and you will get a value 1.96 times 10 to the power 8 meter per second, which is 2. The next one, Formula 14, electric charge. Electric charge is being calculated from Q8. Q8, the charge must be measured in coulomb, current must be measured in ampere, and the time must be in second. Right? Remember that. And sometimes, okay, this Q represents total charge, remember. So sometimes the question asks you to find the number of charged particles in the metal. Total charge, that means, right, it is related to, because out of these two charges, electron and proton, only electrons can move. So it is the number of electrons that flows through the conductor that give you the total charge. So total charge can be calculated by the number of electrons times the charge of one electron. The charge of the electron is 1.6 times 10 to the power negative 19 coulomb. That is how you calculate your total charge, right? And electric current, you just inverse, okay? Invert it. I is equal to Q over T. Current is measured in ampere, charge is measured in coulomb, and time is measured in second. That's all. Now, let us look at one of the past year question here. Which combination of the current in the resistor and the time for which it is present results in a charge of 240 coulomb passing through the resistor? Now, I want my total charge to be equal to 240 coulomb. Remember how we calculate the charge? It is current multiplied by time. But time must be in second. Remember that. Let us look at the first one. A. Current is 2 ampere times 120. So I get 240 coulomb. Actually, A is the answer, but I will prove B, C, and D are wrong answer, right? The second one, 4 ampere times 960, you will get 3,840 coulomb. Third, right, the current is 6 ampere, but the time is 40 minutes. I have to change that minute to second. So I'll get 144, okay, 14,400 coulomb. And D, current is 8 ampere, but the time given is in minutes. So I have to change that minute to second. So I multiply by 60. I also get the same answer, 14,400 coulomb. So A is the answer. The next formula is Ohm's law. Still remember Ohm's law? V is equal to IR. V is called potential difference, PD. I is current. R is the resistance. Current must be measured in ampere. Resistance must be measured in ohm. PD must be measured in volt. And then electrical energy, there are 3 equations which you have to memorize. E is equal to VIT. E is equal to I square RT. E is equal to V square over R times T. So energy, electrical energy must be measured in joules. So potential difference must be in volt, current must be in ampere, and T, time must be in second. Energy must be in joules, current must be in ampere, resistance must be in ohm, and time must be in second. Energy must be in joules, potential difference must be in volt, resistance must be in ohm, and time must be in second. Remember that. And the electrical power, right? We also have 3 equations. Power is equal to IV, power is equal to I square R, power is equal to V square over R. Power must be measured in watt. So that is why current must be in ampere, PD must be in volt. Power is in watt, current must be in ampere, and the resistance must be in ohm. Power must be measured in watt, potential difference must be in volt, resistance must be in ohm. That's all. Now, let us look at this question. An electric fire is connected to 240 volt supply and transfer energy at a rate of 1 kilowatt. Energy at a rate. This is actually power. How much charge passes through the fire in 1 hour? Right, I need the charge. Power, how do I relate to charge? Okay, charge I can relate to current. Q equal to IT. I don't have the current, so I need to find the value of the current first. Energy, okay, this is power. Power is equal to IV. Power is 1 kilowatt. Power, remember I told you it has to be in watt. So kilowatt, you change to watt times 1,000. So 1 times 1,000. Current, I need to find. Potential difference is given in volt, so just put volt. I is equal to 1,000 divided by 240. So you will get 4.17 ampere. So since I get the current, I can find my charge. Charge is equal to 4.17 ampere times the time. Time must be in second, but the time given is in hour. 1 hour you have 60 minutes, 1 minute you have 60 seconds. So therefore you will get 1.5 times 10 to the power of 5 times 10 to the power of 4 coulomb. C is the answer. The next one. A resistor transfers 100 joules of energy when a charge of 10 coulomb flows through it. What is the potential difference across the resistor? So now energy is given. So just put E equal to VIT. So do you still remember Q is equal to IT? So the whole thing here, I'm going to replace with Q. So E is equal to VQ. So E is 100 joules. Potential, it is already in joules, so I'm not going to calculate, I'm not going to multiply or divide with anything else. V, I don't know. Charge is already in coulomb, so just put 10. V is equal to 100 divided by 10. So it is 10 volt. B is the answer. Now, The next one. Okay, a battery is connected to a circuit. It is switched on for 1 minute. During that time, there is a current of 0.4 ampere in the circuit, and the battery supplies a total of 48 joules of energy. Which rho gives the charge that passes an electromotive force of the battery? Charge, very simple. Just put charge is equal to current multiplied by time. Current is given as 0.4 ampere. Just put 0.4 ampere times the time, 1 minute. You have to change to second. Remember what I told you? 1 minute is equal to 60 seconds. So you times 60, here you will get 24 coulomb. And then the energy, remember what I told you? E equal to VIT. And IT is equal to charge. So I'm going to use E equal to VQ. Energy is 48 joules. V I don't know, but the charge is 24. So V is equal to 48 divided by 24. So this is 2 volt. C is the answer. The next one. In the circuit shown, the ammeter reads 2 ampere and the voltmeter reads 12 volt. How much energy is transferred by the resistor in 10 seconds? So when they ask about energy, this is the most popular equation, VIT. I love to use this. Right, so volt, 12 volt, I is 2 ampere, just put 2, and the time is in second, just times 10. So you will get 240 joules, so C is the answer. The next one, formula 16, total resistance for series. For series, it depends on the number of resistors arranged side by side, right? So series, you just add up. The total resistance will be R1 plus R2 plus R3. If there are 3 resistors, remember, R1, R2, R3. Just add up R1, R2, R3. These are called series circuit. Total resistance for parallel is like this. Okay, they are on top, okay, below each other. So this is called parallel, R1, R2, and R3. So it is 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3. Let us try one passive question right here. Diagram shows 2 resistors connected in a circuit. What could be the combined resistance of this arrangement of the resistors? You see that 6 ohm is on top of the 12 ohm. This is called parallel circuit. Parallel circuit, normally they will put a dot here, meaning to say that the current is being splitted out, right? So if you want to calculate, okay, this is parallel. You have to tell yourself this is parallel circuit. You want to calculate the total resistance combined. R1 over R total is equal to 1 over 6 plus 1 over 12. So you get 1 over R total first, which is equal to 1 over 4. And make your R total as the subject. Flip, invert it. So this is equal to 4 ohm. A is the answer. The next formula is potential divider. Potential divider, I want you to bear in mind, this is only valid to series circuit only. So I will draw this out. Okay, this one I call it as V input. This is R1, this is R2, and the voltmeter is being connected to R2, right? So how I do it, as long as you check whether this circuit, you can use Ohm's law actually to solve your equation, you solve for the answer, but I would teach you another way by using a potential divider to solve it, right? So you see that these 2 resistors, look at the 2 resistors, they are connected in series. So when they're connected in series, you can use the ratio. V over V input is equal to R2, the one that is connected to voltmeter, divided by the total resistance of the circuit. That is what we call potential divider concept. Right, so let us try this question right here. First thing you do is to check whether the circuit, oh, they have already mentioned, this is potential divider circuit. So potential divider circuit actually help you to save time. You can actually use Ohm's law. I will show you 2 ways to do it. right? Most of the students, when they see this kind of question, oh, okay, 10 ohm and 20 ohm are being connected in series. So I'm going to use Ohm's law. Okay, this is method number 1. You can use this. But of course, method number 1 is longer. So I'm going to use Ohm's law. V equals IR. I want to find the value of the current. Right, 12 is the total V and EMF of the battery. And I don't know, resistance, because these two 10 ohm and 20 ohm are connected in series. So you just add them out, becomes 30. I is equal to 12 divided by 30, which is equal to 0.4 ampere. So since I know that this is a series circuit, 10 ohm, right, and 20 ohm, they have the same current flowing through them, which is 0.4 ampere. So if I want to find the value reading on the voltmeter, I just use V equal to IR. I is equal to 0.4, R is 20. So you will end up getting 8 volt. Yeah, this is method number 1. So if you want to use potential divider, this is method number 2. I prefer this method. Potential divider, look at voltmeter reading, volt over 12, the total voltage, over is equal to the one that is connected to voltmeter, which is 20 ohm, divided by the total resistance, 20 plus 10. So V over 12 is equal to 20 over 30. V is equal to 12 times 20 divided by 30. So you will end up getting the same answer as well. C is the answer. So if you want faster, right? Now, the next one, I am going to use the potential divider to solve it. And I want you to try this as well, right? Feel free to pause the video and use the potential divider to solve it. It's really save your time, right? So the diagram shows two resistors used as a potential divider. The reading on the voltmeter, which is 1.8 volt. What is the resistance of resistor R? Potential dividers, you remember? So this is 1.8 divided by total voltage, which is 3, equals R over R plus 5. 5 is together with the kilo ohm. I'm not going to change that kilo ohm because I look at all the choices, A, B, C, D, they are in kilo, right? Kilo ohm. Now I do my cross multiplication, 1.8 R plus 5 is equal to 3R. So 1.8, you times in, you get 1.8 R plus 1.8 times 5, you get 9, which is equal to 3R. So you shift this 3R, okay, 9 is equal to 3R minus 1.8R. See that? So that is why, okay, your R, which is equal to 1.2. 9. So R is equal to 9 divided by 1.2, you get 7.5 kilo ohm. C is the answer. Formula number 18, the relationship between resistance and other physical quantities, right? You have to know resistance is directly proportional to length. Resistance is inversely proportional to cross-sectional area. That means thicker the wire, larger the cross-sectional area, smaller the resistance. And cross-sectional area, right? This is what we call cross-sectional area, right? Area is equal to pi r squared because area of the wire, area of the conductor is always area of the circle, pi r squared. But we don't have apparatus in the lab that we can use to measure the radius of the circle. That is why r is equal to diameter over 2. Sub into the equation, you have pi d over 2, you square it. So you have area is equal to pi d squared over 4. Remember this. Since resistance is inversely proportional to area, you can also say that resistance is inversely proportional to diameter squared. Because area is proportional to diameter squared. Okay? Now, one question here. The table describes 4 different resistant wires. They are all made from the same metal. Which wire has the smallest resistance? Smallest resistance, that means smallest length. Because resistance is directly proportional to length. Smallest length, but larger diameter, so that you have larger cross-sectional area. So, B is the answer. Formula number 19, transformer. Transformer, all you need to remember is Vp over Vs is equal to Ns over Np. Vp means primary voltage. Vs means secondary voltage. Ns means number. No, this is not Ns. This is supposed to be Np. So this is Np. P and P stays together. S and S stays together. Number of turns in primary coil. This is the number of turns in secondary coil. See that? Now, okay, if the question mentioned, right, transformer is 100% efficient, I also want you to remember this. 100% efficient, that means total input power of the transformer is equal to total output power. Total input power is related to primary. Current in the primary coil times voltage in the primary coil, because power is equal to IV, remember? So it's equal to current in the secondary coil times the voltage in the secondary coil. Now, look at this question. Diagram shows a transformer. The input voltage is 240 volt. What is the output voltage? What? They want output voltage, that means secondary voltage over primary voltage is equal to number of turns in the secondary coil over number of turns in the primary coil. Secondary voltage, I don't know, but primary voltage I know, which is 240. Number of turns in the secondary coil, which is 40 divided by 800. So secondary voltage or output voltage, 240 times 40 divided by 800. So you're supposed to get 12 volt. B is the answer. The next one, a transformer has 2,400 turns on its primary coil and 200 turns on its secondary coil. What input voltage is needed to give an output voltage of 240 volt? They want input voltage. That means voltage in the primary coil. So I modify. Vp over Vs is equal to Np over Ns. Vp over Vs is 240 and Np primary, which is 2,400 over 200. So primary voltage is 240 times 2400 divided by 200. So your answer should be 2,880 volt. D is the answer. The next question. A transformer is needed to convert a supply of 240 volt AC into 4,800 volt AC. Which pair of coil would be suitable for this transformer? Right? I am finding the ratio of secondary number of turns in the secondary coil divided by number of turns in the primary coil, which is equal to now voltage secondary over voltage primary. So number of turns 4800 divided by 240, I get 20. So the ratio of the secondary voltage to the primary voltage must be 20 as well. So first one, this is number of turns in the, this is okay. The ratio of the number of turns in the secondary coil, because I'm using voltage. Voltage 4,800, secondary voltage divided by primary voltage 240. This is a step-up transformer. So I need to make sure the number of turns in the secondary coil to the number of turns of my primary coil must be equal to the same ratio, which is 20. So first one, Ns divided by Np, 1,000 divided by 50. I get exact 20. Answer should be A, but I just want to make sure that this is not the answer. 48,000 divided by 240, I get 200. B is wrong. 24 divided by 480, I get 0.05. This is also wrong. 100 divided by 2000, I get 0.05. This is also wrong. So the answer is A. The next formula, formula 20, half-life. Half-life is actually the time taken for a radioactive nucleus to decrease to half of its initial activity or initial count rate, doesn't matter. Right? So let us look at the question. A reading is taken every 10 minutes of the number of emissions per second from a radioactive source. The table shows the readings. What is the half-life of the source? If you are not given a graph, you have to look at time. Time start from 0. What is the number of emissions? This is called initial. Okay, initial count rate or initial value of the radioactive source, right? Okay, at half-life, remember, yeah, half-life is the time taken to decrease to half of its initial value. So the initial value is 800, so you divide it by 2, decrease by half, so you get 400. So look at 400, what is the time? The time is 20 minutes, so the half-life is 20 minutes. Let us try another one. A sample of radioactive isotope has an initial rate of emission of 128 counts per minute and half-life of 4 days. How long will it take for the rate of emission to fall to 32 counts per minute? Now, whenever I do it, I don't really use formula. I use table. This is how I do it. If you find that this table, right, is easier to use as compared to equations, feel free to use it. So I jot down, okay, number of initial count rate, okay, which is 128 counts per minute. Time has to be 0. Then, at half-life, 128 would decrease to half of its original value, which is 64. This occur at 1 half-life, which is 4 days. And then, okay, after that, because the decaying graph is exponential, so it keeps on decreasing by 2, right? This is 32. This is already 2 half-life. Why? Because I have divided 2 twice. 2 half-life, so 2 times 4, which is 8 days. I want 32 counts per minute. That is 8 days. So C is the answer. The next one, when a graph is being given, look at the graph. The graph shows the activity of a radioactive source over a period of time. What is the half-life of the source? Look at time. When time is equal, this is 1, 2, 3, yeah? When the time is equal to 0 hour, take the value on your y-axis. That is the initial activity, 2000. So at half-life, the initial activity must decrease to half of its initial value, remember? So you take 2000 divided by 2. So you get 1000. Just look at 1000. What is the time? Right? The time is actually 1 hour. So 1 hour is the answer. Now the next one. The graph shows how the count rate on the detector due to the radioactive source changes with time. What is the count rate at 5 hours? It seems that the graph is incomplete. Don't ever draw on the graph. Don't draw. Okay? Now, first thing, you take initial count rate when time is equal to 0. So just write down initial count rate, which is equal to 4,800 counts per minute, right? At half-life, I want to determine the half-life. Half-life, this initial count rate decreases, right, by half, which is 2,400, right? Counts per minute, right? Look at 2,400. Okay, get the time. Okay, this is actually the half-life. Okay, once I determine the half-life, things are getting easier. So 4,800 times 0 decreases to 2,400. This is 1 half-life, which is 1 hour. So then, okay, decreases again to half of its initial value, half of the value that left, which is 1,200. This is 2 half-life. 2 half-life is 2 hours. 2 times 1, right? And then after that, keep on decreasing. Divided by 2, you get 600. This is 3 half-life. So 3 times 1, so 3 hours. And then after that, divided by 2, I get 300. So this is 4 half-life. So I shift myself away first a bit. 4 half-life, this is, oh, sorry, 4 times 1, because half-life is 1 hour. This is 4 hours. And the last one here, okay, divided by 2. Keep on dividing by 2. This is 150. This is 5 half-life. So this is 5 times 1 hour. So 5 hours. 5 hours, I have 150 counts per minute. So C is the answer. And Formula 21, this is orbital speed. This is related to space physics. Orbital speed can be calculated by 2 pi r over t. This is called period. Period means time taken for one complete oscillation or one orbit circulation. R is the radius of orbit. Okay? Now, let us try with some past year questions. Right, a space station orbits Earth at a distance of 7,000 kilometers from the Earth's center. It takes 15 orbits in every 24 hours and 24-hour period. What is the speed of the space station in its orbit? I know. V is equal to 2 pi r over period. Period is one orbit. So I have 15 orbits in 24 hours. I want only one orbit. So one orbit is equal to 24 divided by 15, which is equal to 1.6 hour. I'm not going to change the kilometer to meter because look at all the units here. Remember, before you convert the units, you have to look at the choices, the unit of the choices given here. So 7,000, I'm going to remain, right? So 2 pi times 7,000 kilometer divided by 1.6 hour, right? So I get 27489 kilometer per hour, rounded off to 27,000 kilometer per hour. D is the answer. The next one, the average distance from the Earth to the Sun is 1.5 times 10 to the power 11 meter. What is the orbital speed of the Earth? Some students say this question is lack of information, so we couldn't solve it, but I'm going to solve it for you. So V is equal to 2 pi r over period. 2 pi, the distance is 1.5 times 10 to the power 11, right? Divided by orbital speed. So this is the Sun, this is the Earth, right? This is called the distance, center to the center, right? 1.5 times 10 to the power 11 meter. Orbital speed, period, right? You know that when the Earth finishes one orbit, that takes 365 days. Not going to change that day to second because look at all the A, B, C, D are in days, right? So I'm going to do that. So you will get 2.58 times 10 to the power of 9 meter per day, sorry. But the question, the choices are in kilometer. If you want to change that meter to kilometer, you have to divide by 1,000. So when you divide by 1,000, you get 2.58 times 10 to the power 6 kilometer per day. 2.58, you round it off to 2.6. That will do, right? So the next tip that I want to give you, tip number 4, is that you really have to take your time to read the question properly. And please beware of the word like constant, the word like not. You know, sometimes we choose the wrong answer just because we forgot that the not exists, right? Or incorrect, or correct, increase, or decrease. So beware of all these keywords here, right? So I test you with one of the question here. The diagram shows that the air molecules in part of the sound wave at a particular moment in time. Which statement is not correct? Not correct. Remember. So sound wave consists of a series of compression, rarefaction, compression, rarefaction. So at X, it is called rarefaction. Right. Earlier, there will be a compression. Yes, before rarefaction, it has to be compression. Yes, this is true. Later, there will be a rarefaction at X. Okay, this is also true. Right. So because the sound wave, yeah, in the sound wave consists of rarefaction and compressions. Right. X can be compression, X can be rarefaction. Right? It doesn't matter. See, the part of the wave is traveling horizontally across the page, which is true because for sound wave, which is longitudinal wave, the vibration must occur parallel to the direction of the transfer of the energy of the wave. Right? Yes. D, the part of the wave is traveling towards the top of the page, going outwards. That is not true. So the not correct is D. Remember. What about this one? Okay, a steel bar is placed in an east-west direction for it to be demagnetized. No other magnet is nearby. Which method is not, remember the not, suitable? Right, I want to demagnetize the bar magnet so I can hammer the bar. Yes, hitting the bar to a very high temperature. Yes, okay, slowly taking the bar out of the coil that carries AC, alternating current. This is yes. The one that is not suitable is slowly taking the bar out of the coil that carries a direct current. Direct current is used to magnetize a bar magnet, a steel bar. Tip number 5. Yeah, sometimes you don't really need to know the exact answer, right? You just need to know which one is not the answer. Just put a cross to it. I believe that when I talk about the formulas that you should remember, I did cross out something there, right? That I am 100% sure that they are not the answer. So eliminate the obvious one so that you will circle the wrong answer. Right? For example, the three students are asked what they understand by the term mass. Their answers are listed. Mass is a property of the object that resists a change in motion. I'm not sure. Second, mass is a quantity of matter an object contain. Not so sure. Third, mass is the effect of gravitational field on an object. No, mass has no effect on the gravitational field. Weight has the effect. So I'm very sure that 3 is not the answer. So the answer is quite obvious, right? B is the answer. Yeah. See that? You are unsure of some of the choices, but you can be sure of one that is not the answer. You will still get the correct answer, right? Now, tip number 6, you have to understand the graph. Right, so if you're scared of physics graph, don't be. They are just lying on drama, a lot of drama here, right? So speed time graph, right? The one that's very important, speed time graph. You have to understand the gradient of the graph represents acceleration. Area under the graph represents the total distance. Distance time graph, you can only find gradient. The gradient of the distance time graph is your speed. That's all. Now, let us try this. The graph shows how the speed of the car varies during the part of the journey. What is the acceleration of the car between 6 seconds? Where is my 6 seconds? It is here. 6 seconds and 10 seconds. When this is a speed time graph, right? If you want to find the acceleration, remember, acceleration is the gradient. Okay, so find the gradient. Get two numbers here, two coordinates. This is 10 and 15, and this is 6 and 10, right? Just find the gradient. Y2, 15 minus 10 divided by 10 minus 6. 5 divided by 4. So your answer is 1.25 meter per second square. C is the answer. The next one, the graphs show distance time graphs for 4 objects. Which graph represents an object which is moving with increasing speed. Now, I want to talk about the graph one by one. This graph A, horizontal line, this is called horizontal line graph. Horizontal line graph will always give you zero gradient. Distance time graph, you bear in mind, gradient represents speed. So since A, I get zero gradient, that means the object is not moving. Okay? B, this graph is called straight line graph. Straight line graph will always give you gradient that is constant. So for B, the object is moving at constant speed because the speed represents the gradient, right? C, this is called curve graph. Curve graph. Curve graph, okay, if you want to see the gradient, whether it's increasing or decreasing, right, you have to draw tangent. What is tangent? Plot points on the graph and draw a line, straight line that passing through that point. You see my tangent is getting towards the x-axis, time axis, right? Becoming more horizontal. That means that tangents are decreasing. When the tangent is decreasing, that also means that gradient decreases. Gradient decreases, that also means that the speed of the object is decreasing. What about D? Okay, D is also called curve graph. So if you want to see whether the speed or the gradient is increasing, you draw tangent. So if your tangents are getting steeper, that means towards y-axis distance, right? So that also means that the tangents increases. The tangent are increasing. When the tangent are increasing, it also means that the gradient increases. Gradient represents speed, so the speed is also increasing. Okay? Now, okay, what about this? Hooke's law, remember? Right, a spring obeys Hooke's law. Which graph is obtained by plotting the extension of the spring against the load? Hooke's law, it is always straight line graph. Whether extension against load or load against extension. No other graphs accepted. Okay, straight line graph starting from origin. But if this is not extension, this is a length, right? Length, remember, if this is a length against load, you have to start from a certain value because the spring has initial length. Okay, as long as the graph is straight, right? Now, tip number 7, quick circuit logic. You just remember these lifesaver. In series circuit, sure the circuit question will be coming out. So in series, you have to remember current is the same, voltage split. Parallel, voltage is the same, current will split. Is that okay? Now, or still confused? Okay. Now, in series, you bear in mind. This is called series. They are connected side by side, right? So, remember this. One breaks, heartbroken. One breaks, that means the circuit is breaking down. You cannot use that anymore, right? It will affect the whole circuit. One light bulb is not functioning, or one light bulb breaks, the other light bulb will not be lighting up. Okay? But in parallel, this is called parallel, right? So you have extra wires must be used, right? They are below each other or on top each other, right? But everyone gets equal love. Oh, sorry, not equal love. Equal voltages, equal potential difference, right? Fair and square, right? That is parallel. Right. Now, tip number 8, right? You need to time management. And my final advice to you is that, okay, you have to spend maybe about 1.5 to 2 minutes per question because you are given 45 minutes and you need time to recheck back whatever mistake that you have done. So give yourself about 1.5 to 2 minutes. But if you face any difficulties, okay, this question require a lot of thinking. Okay, maybe you circle that first on the question paper and skip that question first. Right, and answer the other question. But don't circle every question. Basically, you skip every question. What is this, right? So believe in yourself, right? And you just time yourself. Oh, this is taking too long. So I might want to answer the questions that is about the statements, right? About the law, about the definition first. Okay? And then if it is taking forever, flag it and move on. Don't sing the whole shit. Right, remember, it's not worth to spend a lot of time on one question. Okay? So practice the real past year paper, review your mistake, and build the speed like you are training for the Olympic, right? Physics Olympiad, right? So, all right, legends, right? Those were your final boosts for your IGCSE Physics Paper 2. Remember, read carefully. You eliminate the choices that are not the answers smartly, and don't let the panic monster win. Right? You have worked hard. You have got the formula. You have seen enough the past year's papers to make the Cambridge cry. Now it is time to trust yourself and do the job. Yeah, if this video helped, smash that like button, subscribe, and share this with your friend who face the same problem. And hey, whether you walk out of that exam with a smile or sweaty sigh, yeah, just know, right? One thing, you show up. You gave your best. And that's how A stars are born. Yeah, I wish you all the best, and I will see you in my next video. Bye.